In my last video, we talked about derivatives, what they are, and how to solve them. In this video, we're going to make it much easier to solve derivatives. Because in my last video, we solved derivatives using the equation for derivatives, which is the limit as h approaches 0 of f of x plus h minus f of x divided by h. And this equation is long and a pain in the butt, and we have ways that can make it much easier to solve derivatives. So let's talk about those methods that can make derivatives easier to solve. And some of these methods will have their own lessons in the future. When those videos are posted, I'll link them with the info cards up above in the top right corner. Let's get started. Our first rule is the constant rule. The constant rule states that the derivative d dx of a constant, let's just say c for any constant, is just equal to 0. If you have a constant number, the derivative is always equal to 0. But why is it always equal to 0? Well, let's say we have a graph. We're going to draw that graph over here. And let's say we have a function. We'll do this in red, and our constant function looks like this. And this is at y equals 4. Remember, when we solve for derivatives, the entire point of finding the derivative equation is to find the instantaneous rate of change of a graph at a given point. And this graph doesn't change at any given point. So the derivative equation is always just 0 since nothing ever changes. As a quick example, the derivative d over dx of 7 is just equal to 0. This one's a pretty simple one to understand, but very, very important to remember. Next up, we got the power rule, and this is one of the rules that will have their own video, and that video will be linked up in the top right. The power rule is as follows. The derivative d over dx of some variable, we'll use x, to a power n is equal to n times x to the n minus 1 power. So what we do is we take our original power and we bring it to the front, and then we subtract 1 from this power to get our derivative. In my last video, we did the example of the derivative of x squared, and that took absolutely forever to solve. Now we can make this really easy. First, we want to bring this 2 to the front. So it'll be 2 times x, and then our new exponent we just subtract 1 from. So we take the old exponent, which is 2 minus 1, which is just equal to 2x to the first power. Anything to the first power is just whatever the original number was. So x to the first power is still just x, therefore we don't need to write that power, it's just 2x. So that's the power rule. Like I said, I'm going to do another video on this more in depth because there's a lot of ways we can use the power rule that you may not think of off the top of your head. The third rule is actually 2 rules, but they're basically the same thing, is the sum and difference rule. So the sum and difference rule states that the derivative d over dx of f of x, or whatever variable is in here, plus another function g of x, just 2 different functions being added together, is the same thing as the derivative d over dx of f of x plus the derivative of g of x, the other function. In other words, we can split any derivative by addition. And you may notice I also wrote difference here. We can also do this for subtraction, so I'm just going to write it here. We can split any derivative by addition and subtraction and still get the same answer. In other words, we can solve for each derivative individually first and then just add or subtract them to combine it to find our derivative of our original equation. Let's do a quick example, and let's do it in red just for fun. Our example here will be the derivative of x squared plus 3. We can split this into the derivative d dx of x squared plus the derivative d over dx of 3. Using our power rule, the derivative of x squared turns into 2x, and using our constant rule, the derivative of 3 is just 0, so this derivative is just 2x. And we could do the same thing for subtraction, just replacing with this plus with a minus. Now rule number 4 and 5 are a bit longer, so I'm going to erase this to give myself plenty of room to work with. Rule number 4 is the product rule. Similarly to the sum and difference rule, we have a special rule for finding 2 functions being multiplied together and using that to find the derivative. But this one's a lot different than the sum and difference rule, and that's why it gets its own category. You see, the product rule isn't as simple as the sum and difference rule where we can just find the derivatives and then multiply them by each other. This one has its own special equation. If we want to find the derivative of f of x, one function, times g of x, another function, we have to do this. This is equal to f prime of x times g of x. Remember, f prime is just the derivative of f of x plus f of x times g prime of x. So the derivative of our second function. So all we have to do is find the derivative of f of x and g of x and then multiply it by its correspondent to find our new derivative. Let's do a quick example. And we'll use red, once again, just for fun. So our example will be 3x squared times 7x. What is the derivative of this function? Well, let's use our product rule. So first, let's establish what f and g of x are. F of x will be 3x squared, it's just the first one. And g of x will be 7x, and this is g of x. So using that, let's find f prime of x, in other words, the derivative of f of x. We'll do it up here in this corner because we have the room. So the derivative of 3x squared can simply be solved by using the power rule. We can pull this 2 to the front, so this would then turn to 3 times 2 multiplied by x to the 2 minus 1 power. Remember our power rule, we just bring whatever our power is to the front, multiply by whatever's in front, and then subtract 1 from the exponent. This is now equal to 6x. So f prime of x is 6x. So let's plug that in over here. So it'll be 6x times g of x, which is just 7x. Now we have to add f of x times g prime of x. We already know what f of x is. That's just 3x squared. And let's find g prime of x. We'll do that over here in this corner because I don't have room here. So to find g prime of x, we actually need to use the power rule, which may sound weird because there's not a power here, but let me show you what happens here. If we want to find the derivative of 7x, there is a power here of 1. We just don't write it because we don't need to show it. So what happens is we pull down this 1 to the front. So this is equal to 7 times 1, which doesn't really change anything, times x to the 1 minus 1 power. This puts our x variable to the 0th power, and anything to the 0th power is just 1. 7 times 1, of course, is just 1, so the derivative of 7x is just 7. So we just multiply 3x squared by 7. And now it's just a matter of multiplying everything together and adding them. 6 times 7 is 42, and x times x is x squared. So the first part is just 42x squared. 7 times 3 is 21, and we just have an x squared. So this is now equal to 21x squared. And we have a common factor, which means we can just add these two together. 42 plus 21 is equal to 63. So the derivative of 3x squared times 7x is just 63x squared. And I know all this power rule stuff may be a little bit confusing. If you need more details about the power rule, go watch my video on the power rule. This will help clear this up tremendously. There will also be an individual lesson on the product rule because this is another thing that takes a lot of practice to get used to. So if you'd like to watch that, you can click the info card in the top right corner. We have 2 more properties to go over. Property number 5, let me get my black pen out. Property number 5 is the quotient rule. We use this rule when we are dividing 2 functions, but it also has its own special rule. The derivative of one function, f of x, being divided by another function, g of x, is equal to g of x, this denominator, times f prime of x, the numerator's derivative, minus f of x, the numerator, times g prime of x, the derivative of the denominator, all divided by g of x squared, the denominator squared. So this function is kind of long, but we have to do this in order to find the derivative of 2 functions being divided by each other. Let's do an example to make this a little bit more clear. So our example down here is the derivative 3x divided by 7x squared. So just like with the product rule, let's establish what f and g of x are. F of x will always be your numerator, so in this case 3x is f of x, and g of x will always be your denominator, so 7x squared is our g of x. Now remember, we must keep this order in mind with the quotient rule. With the product rule, you could have flipped these two and it doesn't matter because they're being added. With subtraction, we must do this and then subtract this from that. So let's keep that order in mind. First of all, let's find f prime of x and g prime of x. In other words, the derivatives of f of x and g of x. Similarly to 7x, the derivative of 3x is just 3, using the same rule as before, but with the number 3 instead of 7. So we need to multiply that by g of x. G of x is 7x squared, and that is being multiplied by 3. Now we need to subtract f of x, of course just being 3x, and multiplying that by g prime of x. We can find this derivative using the power rule, so let's do that over here. The derivative of 7x squared using the power rule is equal to 2, bringing down this to the front, bringing down this exponent 2 to the front, times 7, which was our original coefficient, times x, and then subtracting 1 from our exponent, 2 minus 1. So this turns into 14. 2 times 7 is 14. times x to the first power, which we don't need to write. So the derivative of 7x squared is just 14x. So we just multiply 3x by 14x. And on the bottom, we just have g of x squared, which means we just need to square 7x squared. So this is equal to 7x squared squared. Let's multiply these out and combine like terms. 7x squared times 3 is just going to be 7 times 3 and tacking an x squared onto the front. 7 times 3 is just equal to 21. So this is 21x squared. 3 times 14 is equal to 42. X times x is equal to x squared. So we subtract 42x squared. And this is all divided by 7x squared squared. We can combine like terms here. So this is now equal to negative 21x squared divided by 7x squared squared. To square 7x squared, we just need to multiply 7x squared by 7x squared. So this is now equal to negative 21x squared divided by 49x to the fourth. We can actually cancel out these x's on top and bottom. So we get rid of the x squared entirely and change this into x squared. This is now equal to negative 21 divided by 49x squared. And we can divide both the top and bottom by 7. 49 divided by 7 is just 7. Negative 21 divided by 7 is negative 3. So the derivative of 3x divided by 7x squared is just equal to negative 3 divided by 7x squared. Now, I will admit, the quotient rule is not the easiest way to find this derivative, but it is a good example to use just as something basic to understand quotient rule. If you'd like more detail on quotient rule, my quotient rule lesson is linked in the top right. And the last property I want to go over is one I just kind of forgot to mention earlier. Property number 6 is the constant multiple law, or I guess constant multiple rule. And we could have used this to make the quotient rule problem we just did much easier. Essentially what this says is in order to find the derivative of something, let's just say c, a constant multiplied by a variable, we can actually pull this constant out of the derivative. So this would be equal to c times the derivative of our f of x function, which I just wrote as x, but x could be any function. If we have a constant being multiplied by our entire function, we can actually pull it out to the front, then find the derivative of this inside function first, and then multiply it by c. So referring back to what I meant by making the quotient rule problem a little easier, if we have this same example, the example we just did a minute ago, the derivative of 3x divided by 7x squared. You may be thinking there isn't anything being multiplied by the entire function here, and that's where you'd be wrong. This 3/7 is being multiplied by the whole function, and this is a constant that we can pull out. This is now equal to 3/7 times the derivative of x divided by x squared. We can simplify this down a little bit to be 3/7 times the derivative of 1 divided by x. We can cancel out the x on top and get rid of 1x on bottom. So now we just have to find the derivative of 1 divided by x. And in this video, I won't show you how to find this derivative, but I will tell you that this derivative is equal to negative 1 divided by x squared. And now we can just multiply that by 3/7. So 3/7 times negative 1 divided by x squared is just equal to negative 3 divided by 7x squared, which is what we found last time. I'm sorry to put you through that whole quotient rule for a problem that was much easier, but I figured you should know the quotient rule and use it a few times because you will need it for some problems where the quotient rule is absolutely necessary. Thanks for watching this lesson. I do want to remind you one more time that lessons for quotient rule, product rule, and power rule are all linked in the top right corner and also in this Calculus 1 playlist, which has every single Calculus 1 lesson on this channel. If you need more Calculus 1 help, consider subscribing because I will be uploading a bunch of them over the next couple of weeks. And if they're already uploaded, then great, just go to the playlist and go watch them. I'll see you guys in the next lesson.